We're in Math 25, week 3, Thursday. And last time when we were looking at the lecture notes for Tuesday's class, we didn't quite get to every problem. So rather than using the old Jamboard, we have copied those problems to a new Jamboard for a new morning. And we can write about the ones that were blank before. So keep reviewing things before we move on to bell curves. In this problem, and these are all just again from the random problems of the homework in health decisions and in typicality from personal finance. Recipe makes 24 servings, requires 12 pounds of carrots. We want to make a recipe that serves 239. So our first step is to scale up the whole recipe. And make this a little bigger. Size is kind of vague. Why don't I call it servings? So we had 24 servings and 12 pounds. That was one situation. And then I, as I'm doing any kind of proportion problem, stop reading and say, if I put servings on top once, I have to put servings on top a second time. If I put pounds on the bottom once, I have to put pounds on the bottom a second time. Now I can keep reading, and there's this bunch of distracting stuff. Yield, percent, don't care about that. And then I say, aha, I want 239 servings. So I keep filling that in. And I'm not sure how many pounds to make. So I'll cross multiply. Can I draw better than that? We've talked many times about when you can use the shortcut and things like that. I am not using the shortcut just because I don't need to. It will fit on the screen. If you need more of this particular problem, we did a bunch of them in office hours study session last time. So look at the study session, and there's more of them like this. To get y by itself, the opposite of times 24 is divided by 24. And they get about 147 servings. Not servings, pounds. So that's how many pounds I need to actually cook with. If I went to the store and bought that many pounds, by the time I trim the carrots, I'd have too few. So we need to do step 2 is the scaling for our yield percent. So I take the 147 I just got. This is where I need the 81%.
Did I miss something here?
Did you miss something? I don't know.
Well, because down there you have 12 times 293. Isn't the servings 239?
Oh, yeah, because I'm just being a little dyslexic. Let me fix all that then. Thank you for pointing that out. So that will change, that will change. Good eyes, thank you for pointing that out. Okay, 239. So 2868.
Should come up with 119.5.
Okay, so I'll round it up to 120 just so we don't run out of food. Might as well round up. Okay, so what I was about to ask, thank you again, is why are we dividing instead of multiplying? I explained that last time. Who wants to explain it this time? And it's not 81.
Because one makes it bigger. One makes it bigger, smaller.
Right. If we were multiplying by 0.81, we'd make it smaller. That's the direction of from the scale at the store to the pot. When we're going the other direction, then we need to divide to make it bigger. So 120 divided by 0.81. So we need to actually shop for more like 148 pounds. And the last step is actual cost. So we just decided we were about to buy 148 pounds. It costs 53 cents per pound. And we get about $78.52. I don't care what we round to in this problem. That would very much be based on your restaurant's policy, not on the fact that the math says it's 0.518, so we round up to 0.52. Questions on any of that?
Nope.
Thank you again for catching my numbered juxtaposition.
Absolutely.
So lots of little steps. This is like writing a bicycle. Practice it a bunch. You're not necessarily practicing it because any one step is hard. You're just practicing it because there's lots of steps and you don't want to be like me and make some careless mistake when it actually matters.
I do it all the time.
We all do. When I first started teaching,
Me.
I had all of my example problems written out in notes. And so I was just copying from that to the board. And that caused two problems. First of all, I would write too fast. So the students who were trying to write in their notes couldn't keep up. And second, I never made mistakes because I had done everything out in advance when I was calm and thinking about the math and not trying to think about lecturing and so on. So I wound up with the false impression that somehow I was a magic person that never made careless math mistakes. So. Okay, 1 gallon of heavy cream weighs 8.4 pounds. What's the weight of 10.5 cups of heavy cream? So if I'm trying to make a proportion, don't write this. If I was, I could say 1 gallon weighs 8.4 pounds. And if one side of my proportion has those words, the other side should also. But then when I come over and keep reading, I have cups. I don't have gallons. So that's not going to work, which is why I told you not to write that. What should I write instead? I can write pounds. Pounds was great.
Cups.
Cups. Yeah. The situation I'm looking for is 10.5 cups. If I have cups on top, I need to have cups on top all the time. So 1 gallon is how many cups? Remember the picture we had in our notes?
16. 16.
16. Put a 16 here. And now I have a proportion that works. I didn't use the shortcut last time. Let's use it this time. Again, if you're not going on to other math classes, then this is a perfectly fine shortcut. So I'm going to take the two that are opposite, oops, each other and multiply those, and then take the one that's by itself and divide. Whatever that is.
5.5.
So about 5.5 pounds. Questions on that one?
We have to.
All set?
I was thinking that we had one more step, but we wanted the weight, not the cups.
All right, we were given the cups. We just needed the weight.
Yes.
So this is an easy one to make harder than it is. Okay, express. Whoop, that one's broken. There's no tablespoons here. So let's find a new one that's better. Da-da-da. Okay, there we go. That's what it's supposed to look like. So we have two cups, and that's just going to hang out in front. We don't do anything with those two cups. Then we also have the 0.125 cups, and that's going to turn into the tablespoons. So what this problem is actually asking is 0.125 cups is how many tablespoons? Everyone understand my setup?
Mm-hmm.
When I'm done, I'm just going to stick a 2 in front of it for the 2 cups. Okay, how do I get from cups to tablespoons? So again, if you've done this a lot, you know what to do. You can just multiply or divide by a number. If you haven't done it that much to make it quick and reliable in your intuition, then do it the slower but guaranteed to not mess up way with another proportion. Actually, I'm going to put my generic one on the left since I always do that. So in general, how many cups are in a tablespoon? Or how many tablespoons are in a cup?
For some reason, I want to say 16, but I'm not sure.
Should we go back and look?
16 in a cup.
16 in a cup, yeah. So that's just something to have in our notes. So 1 cup equals. So y times 1 is y, 16 times 0.125. So 2. So we have the 2 cups, that's just there. And the 2 tablespoons, because that's how much the fractional amount, or the decimal amount of the cups was. Questions about that slide? No? Oh, okay. This one is kind of different. 20 teaspoons is 6 tablespoons and some other amount of teaspoons. So how many teaspoons are in a tablespoon?
3.
3. So for most people, the easiest way to do this one is to just draw some pictures. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So how many groups of 3 do we have? 6 times 3 is 18, and we have 2 more. So each of these, we can say that 3 teaspoons is a tablespoon. So we wind up with 6 of those tablespoons. And then how many were left over? 2 teaspoons. If you don't like the diagrams, don't do the diagrams. Do 20 divided by 3 is 6 with a remainder of 2 and get it that way. But people tend to not like long division with remainders and think that this is nicer. Whatever works for you. As I mentioned before, if you've done a lot in the kitchen, this is too much writing. You'll know that, since there's 16 tablespoons in a cup, I'm either going to multiply or divide by 16. And since I've done this a lot, I know it's multiplying by 16 in this case. But if you don't have that intuition, then just write a little bit. It doesn't take that long. You have plenty of time on the final, and you don't have to worry about, do I multiply or do I divide? Because the proportion will tell you. All you have to remember is to put the same label on top and on bottom. Similarly for this one, if you have done this a lot, you'd say, 20 divided by 3. That gets me 6, and there's a remainder of 2. But if you haven't done it a lot, if your mental math isn't trained to be reliable in that way, then just do something else. It doesn't take that long. Okay, how do I find the mean of numbers?
Multiply them divided by how many numbers are there?
Yeah, so the total, I'm not going to bother to write them out again. Let's see, 95 plus 45 plus 41 plus 4 plus 33 plus 22, so 240. How many? There were 6 of them.
40.
Yeah, 6 times 4 is 24, so we get 40. There's no label. It doesn't tell me if these are pounds or dollars or people or whatever we're counting, so no label. How do I find the median?
Isn't that where you write them out in order and then
Yes.
find the middle number?
Crystal is on a roll. right? What's not on in? So they're not in order. I have to make them in order, and then I have to pick the middle.
Mm.
So my smallest one is the 4. And it doesn't hurt to just cross them out as we're going. Make sure we're not double counting any. 22,
Yes, but we have 2 middles.
we do. Remember the last part of this of what to do if there's 2 middles?
That I
Take 'em
don't
both.
remember.
So there's our middle.
I didn't know this part.
Because it's the middle, then we have to do this process, the mean, for the 2 in the middle.
Oh,
So add them together, divide by 2. So we'll get 74, which would be
37.
37. Questions about that?
Nope.
Okay.
Here you can't. No, you can go watch it in your room though, okay? Mommy's in the middle of class right now.
Play with my tablet.
Okay, that's fine.
Okay, so that's where we ended up. If you remember, we were talking about mean and median. Let me make this a little bigger. Is that big enough on the screen for my font?
Yep.
Okay. So we were talking about that. There was that problem where the preschoolers had their stuffed animals, and the stuffed animals were bringing the average down too much when we used this kind of average. They were given just as much weight and importance as the actual preschoolers. So we wound up with a mean that was higher than any stuffed animal and lower than any preschooler. It was not representative of what was happening in the classroom. When we used the median instead, then it was a better number. It was still smaller than the mean, but that median found out something that was at least kind of representative. And we talked about how if you're doing the average price of a house in a neighborhood or the average price of someone's salary or things like that, there's lots of real life demographics where a few values that are much bigger or smaller than the rest might make the mean not actually have anything that's typical or representative or a good example of what's happening in that area, but the median does a better job. The last one I want to mention is the mode. If you look in the random problems, there's no mode. We never use the mode. The mode is just there. It's traditional when I teach you mean and median to teach you the mode, but it's not really a math thing. The mode of a group of numbers is the one that appears most often. It's like we're voting. So you just look at the list and pick the one that appears most often. In this case, there
36.
are 36 because there's 3 36s. If it's a tie, all the ties are modes. So you might hear mean, median, and mode. Now you are well educated and know that those go together, and mode is a certain kind of thing. But the kinds of things we use math for, mode doesn't help. It's just kind of the fancy name for voting on something. If we had the factfulness book, we could talk about how this applies to that, but we don't. I can't pass the book out to you. If you want me to pass out either printed packets of all this website or books from our class library, let me know. They're all home in my garage. I can work on trying to get things to you sometime in an appropriate way. But let's not do that right now. Okay, the next topic is bell curves. If you look in the random problems, then there's nothing for bell curves. This just doesn't work to make some random thing and ask you about it. So this won't be on the test because these random problems, again, are the same problems used on the test. So here's a whole little section just about you being a well-educated citizen and person, and there's no problems on this. So if that puts your mind at ease, then know that in advance. We talked about histograms a lot, and we mentioned before this thing called standard deviation. If the deviation is small, very few things deviate from the middle. There's a good representation that, yeah, this population of whatever, heights, weights, incomes, housing prices, costs of stuffed animals, yeah, there are typical examples here. There are representative things here. If the standard deviation was large, then we've measured something, but there's no one value that really represents the data. Either there's extremes or more than one clump, or everyone's about the same. And we talked about how the more there's extremes, the more there's deviation from the middle. So we're going to look at the ones that are nicest. When there is a symmetrical clump, these are called bell curves. Other jargon is a normal curve or a normal distribution. The very most generic ones are completely symmetrical. There's as many things bigger as there are smaller. Many bell curves are skewed. If there's more things that are smaller than average, it will look like the clump on the left. If there are more values that are larger than average, it will look like the clump on the right. So bell curves can happen when there's an average result that's the most common, and being higher or lower than average is pretty much equally likely. Being way higher or lower than average is always rare. Even on the skewed cases, the extremes on the far right and far left are almost zero. That makes sense? If we're measuring heights, depending on where we're going in the world, people will have an average height. Some people will be taller. Some people will be shorter. There are a very few people who are giants or midgets, but most people are about the middle. And in some populations, there'll be more people that are slightly above average than below. In other populations, there'll be more people that are slightly below average than above. Okay so far? Okay, we're going to find the sum of two dice and make a bell curve. If you have a six-sided dice or two six-sided dice, then you can go grab some. If not, I'm going to show you how to do that on the computer randomly. So if you don't have two dice, then open a new browser window and make a Google Doc. If you need help with that, then I can help you, or you can just, and I said the wrong thing, not a Google Doc, a Google Sheet. If you have a favorite spreadsheet program of your own, that works fine. If you have Excel or OpenOffice Calc or something on your computer, then there we go. If you have a spreadsheet open or a pair of dice in front of you, then we can make random numbers. If this is too much hassle, you can just watch, that's okay. With the spreadsheet, you can type equals rand and then open and close parentheses, and you get a random number between 0 and 1. Let me make this a little bigger. I don't want to simulate a random number between 0 and 1. I want to simulate a six-sided die. So I'm going to hit equals, click on that, and then times, which is my asterisk 6. And that's a pretty funny die, rolling 1.8. So I'm going to hit equals and type, let's round that, open my parentheses, click that, close it, and back. So I have a random number with no things in the parentheses. Let's take this and multiply it by 6, and let's round the thing to the left. And if I do that a bunch of times, then I have different random dice rolls, and I'm rolling really lucky here. There's data. Do they have a hotkey for you here, or do I just tell you? There should be recalculate. Oops, not format. To roll your dice again.
Luckily, I have a dice app on my phone, so.
Okay, if you have a dice app on your phone, that works too. Um,
How many times are we supposed to roll it?
a few, doesn't really matter. We're going to make a bell curve together.
Gotcha. Patches, what are you yelling about? Come here.
Window.
Come here. Come here, boy.
Okay. In any case, I've rolled the dice. I have 1, 2, 3, 4, 5, 6 fives. So I'm going to take, there it is, this thing. Oh, whoops, I'm sorry, I did it wrong. We're supposed to be adding 2 dice together. So I'm going to say that we have, actually, I'm just going to get some dice.
No, Patches. Quit it.
That will be easier. Okay, I have some dice. I don't want to distract people with the spreadsheet when that's not really the point. Okay, so I'll roll dice. 4 and 5 is 9. Someone else call out a dice roll they've done one way or another.
6.
So 2 numbers adding up to 6. Okay, someone else take a turn.
1.
1. How do you get 1 with the sum of 2 dice? That's not going to work.
I didn't know it was 2 dice.
Yeah, add up 2 dice.
9.
Yeah, 5. I'll take a turn. 8.
10.
And Cade, come roll some dice or pretend you did. Type something in chat if you don't want to share your voice.
2.
Just, you quit yelling, you crazy cat. What is your deal?
6 and 3. I rolled a 9.
Go out, go out. Get out of here, man. Crazy.
More dice rolls. Keep calling them out. Or type them in chat or something.
10.
And I get an 11.
9.
Getting lots of 9s.
4.
4. I got a 5. Another 4.
Another 4.
4.
Another 4.
Yes.
Okay, and I just rolled another 4.
10.
Winning. 5,
6.
6,
10.
8, another 10. Okay, I'm going to stop for now. At this point, our histogram does not look like a bell curve. It is not true that we have some sort of most popular central thing and then it fades off to the sides. If we were to keep rolling 2 dice and finding their sum again and again and again and again hundreds of times, it would look like that. 7 would be the most common and it would fade off from there. So the point of this exercise was merely to say that a small sample size breaks your bell curve. The randomness will override whatever actual pattern is there. If I'm rolling dice, it works. If I'm just saying what's the average height of somebody in Eugene and I only measured 10 people, then all of that is not going to give me accurate representation of what's happening. So you need a big sample size. And if you want, you could just keep rolling dice and see how the histogram kind of fills in and turns into a bell curve. But I'm not going to waste our class time rolling dice again and again.
Oh, why not? It's fun.
So there are a few physical characteristics that make bell curves. Random events can, like adding dice. Heights and weights will. Anyone know what other natural physical characteristics of people form bell curves?
Hair color.
It's not really something where you can measure numbers on the bottom or put things in. And
Well, you know how many people have blonde, how many people have brown.
no, I'll give it away.
Uh,
Vision turns out to be one of them. Most people have close to normal vision. Nearsighted and farsightedness are equally common. There are a lot more people that are a little bit near or farsighted than very much so. Bicep strength works. So if we all got a dumbbell and how many dumbbell curls could we do, then with a small class like this, again, we're going to just have not enough information. But if we had lots of people measuring their bicep strength, then there would be very definitely an average and then the bell-shaped curve to either side. Grip strength is another. And if your population is homogeneous, there hasn't been a lot of immigration or emigration recently, then blood pressure and life expectancy will be two others. And that's about it. So when people try and use bell curves to measure other things about people, whether it's income or intelligence or math tests or things like that, they're doing it wrong. Those things don't normally form a bell curve. You wouldn't expect them to. If you try and force the data to be a bell curve, then something is going to go wrong. Everyone with me so far? Here are two different bell curves. They both have the same average value. It's just, and they both have the same number of people underneath it. It's just that in the pink one, there's a lot more people that are close to average. In the blue one, some of those people are distributed to the sides a little more. More people are funky, above or below average to a more extreme degree. Does that make sense? We already have the vocabulary to describe this. The blue curve has a higher standard deviation. There are more people spread out farther from the middle. Both curves have people at the tail ends. There are some, assuming it's people, really big or really small examples of whatever we're measuring. Okay, so bell curves became very famous with standardized tests. And this is something as students you deserve to know about. So if people want to group people in a way that would be good for academics and make bell curves, like some sort of IQ test or college entrance exam, then you could do that. You would have to try again and again, writing tests, and see if the answers form some sort of bell curve. If most people get about the middle number of problems correct, and an equally balanced number of people get higher or lower, and fewer people get much higher or much lower. And you could imagine altering the test again and again and again, changing what problems are on it until you get this pattern. If too many people are doing really well, then have fewer problems that are that easy. If too few people are doing miserable, then put some easier problems on so everyone can get at least a few, and so on. Does that make sense? If you were to do this again and again, like the SATs do, with enough people that you avoid the problem of not having enough examples in each case, you could write a test with a good bell curve. And that's what the SAT has managed to do. The question is that all we've really done was make a test that fits people in a bell curve. We're not really sure what it measures anymore. So IQ tests are famous for measuring not intelligence, but whatever it is IQ tests measure. And people have studied the SAT tests, and they don't reliably predict whether someone is actually ready for college and will, in a few years, have a college degree. So just be aware of that. If you force things to be in a bell curve, that works. But you can't also claim that it's measuring something other than whatever you forced it to be. Socioeconomic trends are also like that. There are very, very few places in the world where distributions of wealth or income or education are actually bell curves. So if somebody is trying to do a report on Eugene education and their article in the newspaper has some bell curves in it, then that is an alarm bell. Something is suspicious. It is like what we just mentioned with the SAT, where they somehow were picking what to measure in a way that formed a bell curve, but that probably means it's not actually measuring what they started out wanting to measure. The last bit of jargon that you need as a student is grading on a curve. And thankfully, almost everyone that you meet that says they grade on a curve doesn't. It usually means I'm going to give you grades and then fudge things at the end of the term. Maybe it's not exactly a 90 that goes from a B to an A minus, but a 91 will get to do it this term, or something like that. Most LCC instructors don't know the math to know what grading on a curve really is, and they just use this phrase in a sloppy way to say they're going to fiddle a little. But if we're actually being strict, and you deserve to know what the strict definition is, grading on a curve means something that almost no one does, which is great. What it means is that I have given a test so often that I know it will make a bell curve. I have enough people that take the test that we can avoid the too few sample problem, and I know what will make a bell curve. So something like the SAT can do this. And because that works, then even before anyone takes this year's test or this term's final exam or whatever it is, I know if they get a certain number, they will get an A. And if they're between here and here, they get a B. And if they're between here and here, they get a C, or however I break it up. You can imagine the curve having more than 3 colors because we have pluses and minuses and all these other things. So almost no class at LCC has enough students in it to avoid the too few data things, right? Even if something should make a bell curve, it might not. And there's almost no class at LCC where someone has assigned the same test term after term so often that they are confident it will make a bell curve. So we wouldn't expect anyone at LCC to be able to do this the way the SAT company can, because they do have huge populations of students taking their test, and they have done it for many years. So we know before anyone takes the 2020 SAT test that a score of whatever is really good, as opposed to waiting for the current crop of students to take the test, looking at the histogram and saying, oh, okay, well, I guess this is really good because of look where they are. Does that make sense? You're picking your thresholds before anyone takes the test. So that's what grading on a curve means. The grades are only based on the predicted curve, not on what anyone actually does. Okay, one last kind of warning or heads up. There was a book that had this picture in it about how if we have stress, in the sort of therapeutic definition where it's not all bad, if you're too little stressed, then you're sort of half asleep, then it affects your performance. This wasn't anything with careful measurements. The author was just trying to make a point. There's no data set or experiment behind this picture. It's not a bell curve. It has the bins, and it sort of has a histogram of how much is in each bin. So why isn't this a good bell curve? It looks like a bell curve.
1.
I'm going to put it here where we can write on it.
It doesn't reach. It doesn't reach each end. Does that make a difference?
No, that's okay. That's just kind of, yeah, this would be somebody that really was somehow at zero stimulus. They were in a sensory deprivation chamber, so maybe there's really no one like that.
Well, all their points are really close to.
Okay, I'll give it away. So the word performance is bad. To make any histogram, we need to be counting how many things are in each bin, right? How many dice did we roll? How many students got the score? How many people have that weight? How many people are in that income range? So this looks like a bell curve, but what it's measuring on the up and down axis isn't counting how many things are in each bin. So we need to relabel it as something else. If we had like how many people are in each of these categories, then it might be a good bell curve picture. Or maybe it's not people. Maybe instead it is like days per year. This is one person's history for a whole year. Somebody asked Donna, how stressed are you? And this is how often she said things, or so on. So we could imagine that you can replace the up and down axis with several things. But whatever it is, it has to be something we can count. How many of them are in each of these categories? Performance was just too vague. So watch out for that also. You will find news stories, and if the things that are being counted in a bell curve aren't countable things, someone is using the bell curve to try and influence you. They're not actually using math. And that's all there is about bell curves. Hopefully you feel like a good, well-educated person about bell curves. As I mentioned before, there's no work for you about this in the random problems. There is a homework set that talks about stuff. Okay, other questions before we move on to mortgages? No, everything seems good. Let me go back up here. How, again, we organized personal finance is we talked about what typical stuff meant, and we just talked about bell curves, because those are things we need coming up. The actual finance we talk about are two kinds, mortgages and how to save for retirement. And for both of those, having careful vocabulary about what is an average thing, what is a representative amount, what is a typical amount, are most Americans saving for retirement enough, right? For all of those kinds of questions, we'll want to use this vocabulary, which is why we started with stuff that wasn't really about money. But now we're transitioning to the stuff about money. So our big theme for the mortgages topic is how big a home can your household afford, or whatever household we're talking about. So we're just going to pick an example. So the Wall family has a $60,000 a year income, which, by the way, is close to the median income for Oregon and the US overall. Why are we using median here? Because there are homeless people and there are Bill Gates, and we don't care about them. The median was the right tool to say the extreme numbers just don't count in our average. I'm not saying we shouldn't care about homeless people. I am saying that for buying a house, we're not worried about. So there is a general rule for how big your mortgage could be, or apartment payments if you're doing that. you look at two different things. First, you find 35% of your before tax income. Then you, second, find 25% of your after tax income. And your total expenses for housing should be between those two numbers. That's your annual per year amount. So your last step for a monthly payment, because most of us think of housing costs as something we do monthly, is divide by 12. This isn't a rule for everybody. Certain parts of the country you live in, you're going to spend a lot more on housing than other parts of the country. But just as far as what makes people seem successful financially, this is the average rule that people use for the United States. Let's look at our example family. So they're going to say that they spend that 60,000 is their pre-tax income, so 35% of it, and then divide by 12. So that would give us 1,750. They get out their tax papers and they figure out that all their after-tax income is more like 52,000 after paying 8,000 in taxes. So their after-tax income, we would multiply by 25%, 0.25, then do the divide by 12, and they get 1,083. So their monthly mortgage payment should be between those two numbers. As a tangent, has everyone heard about whether or not you should be doing your taxes soon for 2020 based on the economic stimulus? No, okay. If you haven't and you care about that, ask me afterwards. So they think about their priorities and they decide they're going to aim for the lower range. So let's aim for about 1,100 per month. So we've gotten partway there. We started by asking how big a house can they afford, and we figured out what their monthly payment will be based on their before and after tax income. So how big a house can they get for that much? This is a terribly complicated bunch of math because you have the amount that's owed on the loan, the principal, goes down each month when they make a payment. And at the same time, the interest they owe goes up. And trying to watch how both those happens is too complicated for our formulas, so we're not going to have a formula. But there is a process we can do. The annoying name, I'm not sure why they use this, is amortization. Ugh, some days I have trouble saying it. Amortization. That's the paying off debt with repeated scheduled payments that are all the same. And accountants have solved the amortization payment things and given us this chart. So I'm going to take this chart and steal it and put it on our slide. Okay. What it is saying is that if you want to have a certain interest rate and a certain number of years of loan, and it was a $1,000 loan. See the little blue text hiding up at the top that says per 1,000? Then if you paid off the corresponding number, you would pay off the loan after that many years. So let's do a problem. We have a 20-year loan, so we're in this column. I'm actually going to make it a little smaller. And an interest rate of 6%, so we're in that column. So the number we're going to take from the table is $7.16. And that's per 1,000 of loan. Everyone with me so far? How many thousands do we have? We have 130,000. So I have to take that $7.60
So
and I'm going to multiply it by 130.
930.8.
930.8. So every month, that's the right monthly payment. And if they pay that every month, everything will work out nice. Slowly, the loan will get paid off, the interest will build up, and at the end of 20 years, their last payment, it'll all work out, and they'll have paid off their mortgage. You could imagine them going to the bank with a suitcase full of money and handing the bank teller $7.16. And the bank teller says, great, I can give you a $1,000 loan. And then handing them another $7.16. And the bank teller says, you're up to a $2,000 loan. And then handing them another $7.16. And they're up to a $3,000 loan. And if they do that 130 times, then they can get the $130,000 mortgage they want. Everyone okay with how this table works?
Mhm.
No questions yet. Okay, so this is stupid. No one will ever ask you to make a calculation for your own monthly mortgage payment, right? When you buy a house, the bank will tell you what your payment is. You don't have to figure it out. Why are we doing this? So just like at the start of class, we had the yield percent with two directions. The times 0.81 would shrink things from what you buy to what actually goes in the pot. Divided by 0.81 was the other direction, to make it bigger so you know how much to shop for so you don't run out of food. We're doing the same thing now. We're saying that this was one direction with a times 130. That's not what we, or a times 716. That's not what we really care about. We want to go the other direction. So let's look at that kind of problem. I'm going to again get my table ready for us when we need it. Okay, back to our hypothetical family we've been looking at. So their numbers where they want to spend 1,100 per month. And in their case, we're having that the interest rates are 6%, and it's a 30-year loan. So we are at $6 per 1,000 of mortgage. So I'm going to take the 1,100, and instead of doing a times that number, we'll do divided by. I'm going to divide it by, oops,
Isn't it supposed to be 1,100?
It is. I am again switching ones and zeros that are next to it. Thank you.
Mhm.
So this is the same kind of bank teller thing. The Walls walked up to the bank teller and said, I have $1,100 in my suitcase. How big a loan can I have? And the bank teller said, well, give me $6. So they do, and that's $1,000 of loan. Give me $6 again. Now you're up to $2,000 of loan. Give me $6 again. Now you're up to $3,000 of loan, and so on. How many times can they do that before they finally run out? It's 183.
Oh, wow.
Now it's actually 183.3333. I'm just going to round it though. We'll talk about this in a moment. And I'm putting dollars. I shouldn't. That's not right. So they got 183 thousands of loan. Now, no one actually writes your mortgage size 183,000 of loan. We write it as 183,000. If I wanted to be very nice, maybe I'll even label this answer with more than a dollar size. There we go. It's important to notice that I am adding these zeros not because I am multiplying by 1,000 anywhere. It's just that the table is per 1,000 of loan, so I'm actually counting thousands at a time. Okay, I'm going to add some commentary here. So we're dividing because we're using the scale factor backwards, so to speak. When we were doing yield percent, it was designed to go from the grocery store to the pot. That was multiplying. The other way was backwards. We had to divide. When we're using the amortization table, then this scale factor is designed to say, I have this big a loan, what do I pay? Since we're using it backwards, saying how big a loan can I get for my payment, then we divide. Okay, at this point, we're sort of done. They know about how big a house they can get. Has everyone seen Zillow?
Mm-hmm.
If you haven't seen Zillow, it's sometime. You can put in an address and it tells you all the houses around that address and how much they cost and things like that. Unfortunately, real life is complicated, and we are in some ways in Math 25 just estimating things and ignoring complications. But for mortgages, we'll pay attention to a bunch of them. Your home purchase has a down payment. Mortgages have a fee, sometimes called points. Some mortgages require that you pay some monthly payments up front. Sometimes there's inspections and attorney's fees and brokerage fees and titles fees and all these other things. So let's actually finish walking through our example problem in a more realistic way. This might or might not be important for you or your friends and family because, as I mentioned before, this is sort of a good amount to just start working with for window shopping for houses. But if we actually wanted to be careful, let's learn how to be careful. So they find a home for that 183,000, and the down payment is 20%. How do we find 20% of a number?
Multiply.
Times by 0.2.
So So whatever that is,
36.6.
so they don't need a loan for this amount. This they need up front. How much will they actually get a loan for? They were going to have to take the value of the house, subtract away the down payment, and the rest they need a loan for.
$146.4.
And I should probably actually say that that's the actual loan size. Okay, everyone happy with this slide? Then there's more steps. The loan, as we mentioned before, is 30 years and 6%. So we had already taken this table with 30 years and 6% and looked at it. We had done that to get the 183,000. But our actual loan size is smaller because of that down payment. So what we actually need to do then is just take the 146.4 thousands of loan, multiply that by the $6 from the table, and get 878.40. Okay, so this is kind of funky. They started by saying they want to spend 1,100 a month. Because of the down payment reducing the size of the loan, they're only paying 878. But in real life, this is good because they probably don't have $36,600 lying around. Good for them if they do, but most often what happens is the family will go to other relatives or things like that and help kind of scrounge up your down payment, and then you have to pay off those people too. So the fact that their monthly payment to the bank is less than the 1,100 they budgeted is good because you're also helping pay off your down payment from your friends or family or whoever helped you get the down payment together. If you were so wealthy that you had the 36,600 lying around, you could have bought a bigger house because you actually could spend the 1,100 only to the bank. But we're not imagining that people who take Math 25 and their friends have all that kind of money lying around. Okay, everyone clear on this slide?
Mm-hmm.
We're almost done. Actually, I'm going to make this not so wide. So the mortgage has a 3% fee. The actual loan size was the 146,400. So let's deal with that first.
$4,392.
Then the first mortgage payment must be paid up front. So we just did that. That was $878.40.
Ah,
Then there's inspections and other stuff. So 200 and 900. So I'll add everything up. And what do we get? $6,370.40 if I did my calculator pressing correctly. And I'm putting a question mark here. What am I missing in my calculations?
Insurance.
We put that over here in the 900. The big one, the down payment. So I have to take that down payment and add this stuff. And our actual answer is 42,970.40. And then I'm going to erase the similar label over here. Okay, everyone happy with that slide?
Yep.
One of the big issues with outright answers that's very popular for Math 25 students is should we enter by house? What makes more sense? Because in certain parts of Eugene, at least for certain parts of the past decade, then it's been very close. It's not really obvious if owning or renting saves any money compared to the other. So now you have the tools to look at that kind of thing. Okay, to summarize, we did some math. They could spend $1,100 per month and afford a $183,000 home. But because they had $43,000 roughly of upfront costs, mostly the down payment, then what they actually do is they get a smaller size loan and smaller size monthly payments, because they have this big financial burden right away that they're trying to deal with. Any questions on what we've done so far? Okay, so from the point of view of this wall family, we're done. We've solved all the math they need to care about. The bank still has a little bit more going on. How much will they pay over all those 30 years? So their monthly payment was the $878.40. So how much do they pay in 1 month? What do I do? I mean, how much do they pay in 1 year? What do I need to do?
Multiply by 12.
Multiply by 12. But it's not 1 year, it's 30 years.
30.
So we get out whatever this is, 878.40 times 12 times 30. So $316, $316,000, 224. So that's how the bank stays in business. The loan was 146,000 and a bit, and the bank gets back more than twice that, which by the way is typical for a 30-year loan. How much of what they paid is interest? Well, everything they paid is either paying back the loan or it's interest. So I can take this amount subtract away the 146,400. Uh,
169,824.
The interest is larger than the loan size, which again is normal for a 30-year loan. Okay, question on this slide.
Who in the heck would want to pay back a loan over 30 years period of time?
They're actually pretty popular.
Wow. I would go insane. I don't like owing money anywhere.
The longer your loan size, the cheaper the monthly payment, right? If we go back to a slide that has this, if I wanted a 10-year loan, I would be paying almost twice as much per month.
Yeah.
And so if you can't afford that, then you pay a longer thing. Because yes, your interest is higher, but it's so spread out that it feels not so bad. It's easier to shop for your groceries and everything else because the interest is spread out so much. But you do eventually pay more interest. Okay, we have 2 minutes. Let's look a little bit more on what's happening. So the bank could have instead invested money in the stock market. The stock market goes up and down. If you try and get money out when it's below that line, you're losing money on average. If you try and get money out when it's above, then you'd be making a profit. So that's why the bank is doing mortgages. It could have much more money on average investing. We'll talk more about investing later. But then there's risk. If everyone wants to take money out of the bank during a recession, then the bank can't give them all their money back. So instead, the bank takes something that gives them enough money to pay for all their employees and stuff. Because again, this is spread over 30 years. So the bank makes some money, but it's safe, it's reliable. Whoever this Wall family is, we trust them to make their mortgage payments more than we trust that there's no recessions. And we'll talk more about that later. This one, just sort of read on your own. If you're cared about the Great Depression or the 2007 thing, then you now know enough math to understand what's happening with that. The factfulness stuff I really wish I could talk about, but we can't. So we've made it all the way through mortgages, and we need to do lots more example problems. Right? This whole class, we basically just had one example problem. If you go to the homework, it looks very similar. And it even gives you this table. You don't have to have it in your notes. It will be there on the test. Somebody wants to have a certain size they can afford with this many years and this percent. There is this much of a down payment. Find the fee, and so on. So it's not quite as complicated as what we've done. Not all of these details are appropriate for asking you on a test. But we're trying to have a good balance of what's realistic issues to worry about and can you afford the house you want. So ta-da, thank you for showing up for class. If you wanted to talk more about mortgages or taxes or whatever, I'm going to turn off the recording and we're officially done.